DHCP snooping helps preventing unauthorized DHCP servers from assigning IP address to other clients or other devices. Now, let's discuss how it really works. So, DHCP snooping. How it works is it filters DHCP messages on trusted ports. Messages on trusted ports. There. Now what I'm gonna do is I'm gonna create our topology. So this will be our first switch. Actually, this will be the second. We're gonna call this switch 2. There we go. And we're gonna connect our DHCP server. So this is our DHCP server. There. Now this switch 2 is connected to switch 1. This is our switch 1. Okay, and our switch 1 connects to multiple clients. Let's say we have just 2 clients, C1 and we have C2. There. All right, now DHCP snooping by default, all ports are untrusted. By default, all ports are untrusted. What do you mean? Okay, we're gonna talk about the steps and the configuration. Well, not specific configuration, more on the configuration steps later. Now, also take note that we have untrusted ports. We also have trusted ports. And trusted ports are usually the uplink. Okay, I will add here. Trusted ports are usually the uplink. There. Now, let's talk about the steps. The first step is you need to enable DHCP snooping globally. So I will add here enable DHCP snooping, and this is global. Next, you need to enable you have to enable DHCP snooping on a VLAN. It can be a single VLAN or it can be multiple VLANs. Okay, enable snooping on VLAN. Again, it can be a single or multiple VLANs. The third one is once you enable DHCP snooping globally and on a specific VLAN, all ports will be untrusted. Become untrusted. And here's what I'm gonna do. I will use the red marker for the untrusted ports. So what will happen, all ports, in this case, I will mark all active ports. Other ports that is not part of our topology, consider this as inactive ports. So all of the ports here will become untrusted. See that? The ports connected from switch 1 and switch 2 to the clients, also the ports connected to the DHCP server. Okay, now maybe you're thinking, how about trusted ports? Well, that is actually the fourth step. You need to configure trusted ports on uplink ports, okay, or trusted DHCP ports on uplink ports. This is uplink. I'm gonna make this E9 on both switch 2 and switch 1. So these are the trunk ports. And okay, so maybe you're thinking, how would you know which are the uplink ports? Now, the uplink ports is the ports towards to the server. And maybe you're thinking, what are towards the server? Now, note this is toward the client, right? This is also toward the client. So the uplink ports should be this and this. So I'm gonna convert this to blue, which are the trusted port. Okay, so I'm gonna add trusted, and then these are the uplink ports. I'm gonna add an arrow, okay, so that we know these are the untrusted ports, the uplink ports. So the fourth step is very simple. We're going to configure trusted port or trust uplink ports. There. All right, now let's talk about DHCP in actions, how it really works. And what I'm gonna do is I'm gonna bring down this to client because we need more space. So yeah, I need a longer line for client 1 and client 2 towards switch 1. The reason why is we're gonna test it. So client 1 will send the DHCP message. And what is the first DHCP message? This is what we call the DHCP discover message. So this is sent DHCP message. And this is towards to this interface. So it will send to this interface. What will happen is, since this is a DHCP snooping untrusted port, it will do the inspection. So I'm gonna add here inspect. It will inspect this port, and as it traverses from switch 1 to switch 2, it will also inspect this interface. And why? Well, again, we want to prevent unauthorized DHCP servers from assigning IP address, so we need to inspect DHCP messages. Now, assuming that the DHCP messages, in this case DHCP discover messages, are legit, it will be forwarded to our DHCP server. And the DHCP server will reply back with the DHCP offer message. Now, as it's sent to this interface, there is no need for inspection. Okay, as well as to this interface, because they are all, or they're both trusted ports. So it will respond with DHCP offer message, and then the client will send again a DHCP message. This time, this is the DHCP request message. Again, it will have another inspection. So I'm gonna add here ×2 inspection. One is the DHCP discover message, and the second is the DHCP request message. So assuming that the DHCP are all correct, are all legit, this PC will get an IP address and other network information because this is a normal and a legit client. Now, let's talk about how it will work on our second client. Now, what happened here is it's also gonna send DHCP message, okay? But this time, it will be illegit. And what do you mean illegit? Well, during the DHCP message that is sent by the client too, okay? This time, the DHCP snooping will work by dropping this DHCP message. And maybe you're thinking, how? Why will the switch 1, specifically this interface, will drop this DHCP message? All right, so during the inspection and in the event of the switch will discard a DHCP message because, by the way, this is an untrusted port because it's the downlink. All right, so maybe you're thinking, how will it discard the DHCP message? On what occasion? On what scenario? Okay, so there are few scenarios, but we're going to focus on this two most common scenarios. It will discard if the client or this port receive a DHCP server message. And maybe you're thinking, what do you mean by that? You see, this is a DHCP message. The DHCP message from the client side should be DHCP discover and DHCP request. If this is a DHCP offer message, it means it's acting as a DHCP server. And maybe it's trying to offer a DHCP offer message with an IP address to client 1 or other clients. So it's acting a rogue DHCP server. That's why this DHCP message needs to be discarded. All right, the other scenario is inside the DHCP message, there is what we call CHADDR or chatter. If this value is not equal to the source MAC address of the client, It just means that this client is trying to spoof the MAC address that's about to be sent to DHCP server. On these two scenarios, the DHCP messages will be dropped by the switch because again, this guy here is a rogue or unauthorized DHCP server.